Hello and welcome to my combo lords joining me here for a somewhat 6-based episode. So I tried to start this at 6:06 my time, although of course sometimes I'm a minute or two late because I suck with technology. But today's episode's a little 6-based, which I love because that is, in my opinion, the most underrated number, because I've been doing weekly streams on Mondays that I was calling Modular Mondays, so that while we were chatting about various topics, we could additionally be looking at not just six, but different mods. Today being the sixth one of those. Mods being similar to numeral bases, or certain traits are shared between the two, and they're interesting ways to analyze traits of numbers. So today, while we chat about some other topics, including nature and primes and other things, we will also be making some Mod 6 tables, and that is partially why in our thumbnail I held up some glasses that I got once upon a time, not a time too long ago, that are hexagonal lenses, which is a good shape. The hexagon will get a little bit of discussion and a little bit of credit in today's stream, because it is, of course, a six-sided regular polygon. And we could also say that, in a way, it embodies other traits the number 6 has. Like, 6 is a three-vin even number, a multiple of 3 and 2. And as the first three-vin even number, we can say that it's the seed of all of them. Or to be precise, the three-vin even numbers are the multiples of 6. And one thing we'll look at today is how sixes and hexagons can be seen as, in ways, built from 2s and 3s. But 2s and 3s are so powerful, and with the additional fact that we can call most things built out of 1s, that makes 6s, in many ways, built from the first 3 numbers. And being built from the first 3 numbers is a pretty powerful property that we can see in the simplest terms show up in 6 being the third triangular number, 1 plus 2 plus 3, and the third factorial, 1 times 2 times 3. And also will show up other places. One way we can visualize 2s and 3s in a hexagon would be if I imagine this circle and the corners of this hexagon as points on the circle. Well, the hexagon itself is the shape enclosed by connecting each point to the point 1 away from it. Or in other words, making each point hop 1/6 of the way around the circle. Well, if I was on one of these points and then I hopped exactly halfway around the circle, I am on another corner. And any regular polygon, where if I put it on a circle and halfway around the circle keeps me on vertices, we know that it has an even amount of corners and thus an even amount of sides for that type of shape. Similarly, I can go 1/3 of the way around the circle and I will hit another point, and that will be a trait of regular polygons whose amount of corners and sides is 3-vin. And so this is the smallest shape with both of those traits. And not only is 6 built from 2 and 3, but because they're so close, it's built from things without gaps between them. Just 2s and 3s, or 1s, 2s, and 3s, depending how we look at it, which is a lot neater than, say, the number 10, which is built from 2s and 5s, and only multiplicatively. 10, it's harder to get from 2s and 5s using addition, whereas 6 we were able to get either way pretty easily. But even looking at just the multiplication structure, where the reason I bring up 10 is because it's the second smallest square-free semi-prime. Basically numbers whose prime signature, or exponents, the prime signature being the multi-set of exponents in the prime factorization. The numbers whose prime signature is 1, 1, I mentioned once in an episode on the main combo class channel, are the square-free semi-primes, meaning they have 2 prime factors that aren't the same prime. And the smallest of those is 6, and the next smallest is 10, which is using 2 and 5 instead of 2 and 3. But the problem with using your 2 and 5 is you skipped something. You missed the 3. maybe we could have something built around using the 2s, 3s, and 5s, and that's where our 30s and 60s come around. But if we just wanted to build from 2s and 5s without the 3, it seems like we skipped something. Why did we rush our way to 5 without including the next step? And that missing thing in the middle makes base 10 and mod 10 much more unwieldy. In fact, there's a chance this will be the last purely focused Modular Monday where I fully whip up a whole table of everything, because they're going to get a little repetitive at some point. But 6 is so neat that we definitely have to show a few of its traits. And we're going to show how it's built from 2 and 3. We could do something similar with 2 and 5 to build 10, but it would be much sloppier. Now, to clarify about what I mean by mod and base, base is basically, I got my digits in a number, I'm making a representation, and what I call a basic base, which is what many people would assume the only bases are, but of course we can get experimental. A basic base would be one of the sort where it's based around some positive integer we'll call b that we'll say is 2 or greater, because 1 doesn't follow the same rules here, where the digits it uses range from 0 to 1 less than b, and we got our b to the 0th powers place, which always becomes a 1's place, our b's place, our b squared's place, and so on. And the mod patterns are really just looking at patterns of this last digit, at least the mod patterns we've done so far, but that last digit is pretty important. So essentially, if we ask about the last digit in a base, it can be a number between 0 and 1 less than b, and that tells us how much we have left over if we were just dividing by b's. And so how much we have left over in terms of 1s. And that's basically why mods are very similar to the end of the base. If I turn all of the using the digit into, I'm called congruent to this number, and I say that if I take a larger number and I ask what it's congruent to, it's like asking what is the last digit, and my mod is whatever the base would be in this analogy, where we're looking at how much higher than the latest multiple we are when we're just focused on that final place. Somebody's saying that, are we going to get into set theory? And not necessarily right away, but at some point we will. And we'll probably dabble into some of the paradoxes of set theory, some of the classics, when we do some logic episodes. So that'll be in the nearer future. We'll get a hint of set theory through a quicker glance at some of the cool paradoxes involved in it when we do logical paradoxes in some episodes. Then definitely at some point in the future we may do a more thorough explanation, but I don't know how soon that would be. And as for the comment that math's best done outdoors, I definitely agree. Still working on getting the Ethernet set up out here, but that will be set up before too long, I believe. And apart from sometimes internet being weird and sometimes it being noisy out here, everything else is good. You get free squirrels, you get free bird noises, you get cool random little surprises from the wind and the trees and all sorts of stuff. My cats come out here, you get your plants, so a lot of good stuff. And to those who don't understand exactly what I'm talking about, that's okay. You know, when I years ago first watched 3 Blue 1 Brown and Mathologer, I didn't understand all their videos either. Sometimes it's good to just get comfortable with vocabulary that could be in a field, and you know, 10% of what I say is my own combo vocabulary, because I do like to describe things in my own way, and 90% is probably math terms that you will re-encounter whether you are listening to me or not, if you end up watching more math videos. And as for my favorite area of math that a comment asked, I would say that I'm not going to say my lifetime favorite, because I have had various points where I was into different things. I will say my current favorite is number theory, which is focused on patterns such as this and much more, but this type of pattern is certainly in the realm of number theory. Now, when we're looking at the mods, if we're asking about mod 6, it's also going to tell us what patterns does the last digit in base 6 have. And that might tell us things about like when would times tables be easy, what fractions would be easy, and things like that we'll be able to gauge patterns of. In fact, something that I have on my computer here that I should show in the nearer future, because there's a chance it's contributing to making things slow, is a demonstration on Wolfram, which is known for their calculator and stuff, but they also have a lot of little application like interactive whatevers, including one I found where it'll show us fractions in different bases. We'll see how base 6 is not only better than base 10, but also better than base 12, the most frequently recommended alternative base. I'm honestly not so sure, after looking more into it myself, why 12 got so popular over 6. It must be partially that people felt more comfortable adding digits than subtracting them, and partially that if you don't understand much about math, one of the easier things to explain is, well, base 12 would be a little shorter to write some numbers, and base 6 would be a little longer to write some numbers. Not a huge difference on the big scale. And it's a little harder to explain, like, oh, but base 12 would have more fractions with repeating strings, base 12 would have harder times tables, base 12 would have other traits that aren't as neat. So I have leaned more and more toward base 6 being a good alternative for humans. Of course, if we're computers, we might want to use binary, or we might even want to use this one that I'll explain in an episode in not too long, which is the next time we go back to a weird base episode on the main combo class channel. It will probably be the one I will do about what's called balanced ternary, and a alternate version of base 3. And now somebody is asking why a random number is significant. Not going to say the answer, but I'll say that it is a very meme-ish answer. There is an answer. It's a very meme-ish answer that I'm not going to say. And to those who wonder about the clocks, well, I'll explain those further as time goes on, but there's been plenty of explanations about that. Make sure that you're all tuned into the main combo class channel. I did, to a degree, explain things about clocks in an episode about clocks on there. I also put out a new episode on there yesterday, which is a cool one. It's the first math one of grade -2, and it goes into extensions to prime factorizations, one of which is such a good extension that some of you may have heard of it, but it is highly undertaught and not a common part of the definition, and should completely change the definition of prime factorization, in my opinion. And there's also further extensions, so even if you did watch though, or even if you know or guess what the main extension I might mention is, feel free to watch it all if you have time, because not only are there other extensions I threw in, but I think that a good math video can tell a little story, and that's something I try and do, where it's not just about the answer. The answer is a small part of it. The answer is like the punchline of a joke. A punchline's only funny with the context of the joke. And so with a good math episode, you tell a little story and you lead your viewer to as if they discovered the conclusion themselves. And then, that's not always possible, but some road along those lines that you lead the viewer down to put some intuition and some context so that your fact seems magical and cool and makes sense. And otherwise, you not only risk people not understanding your fact, but you risk, when they do understand the fact, you don't present it with any magic. And so that's a goal of a good math episode, and I think you can see it in something as for the channels I like to watch and not, whereas like a channel along the lines of, say, 3 Blue 1 Brown or something is one of the most praised math channels. his videos tell little stories, and they lead you to the conclusions, you know, over the course of the whole video. There are other math creators who are like, seem really smart, but their video right at the beginning is like, here's a fact I'm about to prove. And it's kind of like you blew the chance to tell it as a cool story. And whoever repeats comments a lot, I'm definitely not going to shout you out. It'll be the opposite. You'll get removed if you repeat comments a lot. So, and whoever asked about how far of the levels of what I asked in the episode could you go before we hit ambiguities, that was sort of one of my own main questions near the end, and I'm not sure if it's the type of thing that if you delve into abstract algebra enough is provable that you never hit ambiguities, in which case it would interestingly show things about those numbers, because it would show that not every number is in the set that's reachable. And I'm not sure if that's possible because it relates to, or reminds me of at least, the difficulty of proving that certain numbers are transcendental. Transcendental being the type of numbers that aren't solutions to polynomial type algebraic equations. Different question than the one I asked in the episode, but it did remind me of the difficulty there of knowing certain numbers are transcendental. And for example, there's some videos on the channel Mathologer that if people ever want to really focus on a video as if you're reading a textbook, really hard to understand those videos, took me multiple times, where he goes over proofs that numbers like e or pi are transcendental, meaning they're not an answer to any of a certain type of polynomial equation, and they can't be written in a typical way with square roots and stuff. And it's really, really hard proofs, and like, applause to him for even fitting it in a video. We'll see if I ever manage to personally condense notes that have transcendentality proofs ever show up in one of my videos, but those are pretty dense things, harder to condense in a catchy way. We might do irrationality proofs in the nearer future though, and on a slightly simpler way prove that things like pi or e are irrational. Somebody asked my favorite historical event in mathematics, and I would say a few of my favorites that these actually came up the other day in a stream just because I was mentioning, somebody said, would you do a video about the history of mathematics? And I said, well, that's a little too broad to make one video about. Like, what am I going to do? A 20-hour video? But I could make events about particular things in mathematics, and some of the ones that I could imagine myself making episodes that, you know, a decent portion of the episode goes into the history in addition to the proof or whatever, or in addition to the fact, would be if we go into Galois theory, the guy who helped invent that died in a literal duel when he was very young. When we go into Fermat's last theorem, the margin note that originally made that a historical thing, and also the whole quest of proving it over hundreds of years is very interesting. And those are a few that come to mind off the top of my head, but I'm sure others will come to mind over time. I could imagine doing biography-like episodes about the mathematician Ramanujan. Very unique and innovative and very different approach than other mathematicians. I could imagine doing one about John Conway, who also has a pretty unique way of looking at numbers. I could definitely imagine doing an episode about Euler, just because he's like the god of numbers, and it would just be fun to just, like, I was sort of semi-brainstorming an episode that I was going to call something like, is not enough stuff named after Euler or too much stuff named after Euler? Because there's like hundreds upon hundreds of things named after him, but it's almost debatable whether there should have been more stuff named after him that wasn't fairly named after him, or whether it's a good approach they're taking by sometimes naming it after the second person to find it, just to make it less confusing. Somebody's saying, can I go over? but I will delve deeper into it at points in the future. I will let you know if and when I have figured out how to explain that in a nice way. And if it's loading, stay tuned, people, because it usually is a short-term glitch. So, or come back in a few minutes. We usually ride out the storm. But we will, before too long, get an Ethernet cable. So, yeah, to make sure everyone hears that, so we got to ride out the storm, unfortunately, until I get Ethernet set up. But thank you for sticking around. And there will be other ones. Oh, quaternions. Yes, that was the other one I mentioned last time this came up. Was I want to take a field trip someday to the bridge where William Hamilton carved the quaternion stuff into. And so quaternions do have a great history, and in fact, I almost want to wait to make an episode about them until we can go to that bridge. So, as for if it loads too much, if I notice it glitching, folks, here's what's going to happen. I'll start drawing some stuff on the whiteboard so that as soon as it's fully reloaded, then stuff will appear on the whiteboard. You can still warn me if it's really bad, though. So, let me also plug in the computer just in case that helps at all. And I think that was most of the questions in chat. Sorry if I missed any. Feel free to leave any more if you want, but I'm going to start going back to my modular stuff, which is going to begin with mods 2 and 3. And we're going to use those to conjure mod 6. So, how we're going to do this is okay. This is at risk of a lot of slipping. Hopefully works okay. So, we're going to start with looking at what the mod 2 patterns are and the mod 3 patterns are. And we're going to try and add them up, more like multiply them up into mod 6. And how we're going to do this is in mod 2, we are going to define, well, let's start this way. We're going to note, which something I have noted before, is how mod 2's possible values are 0 and 1. Now, how many ways could those line up with mod 3? Well, there's exactly 6 combos we could have. We have 0 times any of 0, 1, or 2, and 1 mixed with any of those. So, first we would wonder, are any of these traits sort of like overlapping in what sort of nickname I would give them when I'm describing them? And they don't really, because all the combos are the mixes of those nicknames like threeven, even, and stuff like that. As long as we let, let's do it this way. These will all be the zeros to start. As long as we let mod 3 nickname its 2 types of non-threevens. The non-threevens are the throd numbers, and the throds come in 2 types. The pre-threevens and the post-threevens. The post-threevens are 1 in this mod, and they're the numbers that in base 3 have their last digit 1. And the pre-threevens are 2s, and you could call them like doubly post-threeven, but it's a lot neater to see them as 1 less than the next threeven, because every number is either the threeven, 1 after, or 1 before. And every number's similarly, but even closer with these, is either even and or the one after and before. And so in the best of every world, we would think there are 6 different values here. Maybe this helps me with mod 6. Maybe these 6 possible values of mod 6 somehow line up with these. And let's see how they might. If I take 0, 0, that's a threeven even, And that means that it's also a multiple of 6. And so that would be 0 in mod 6 because it's congruent. Now, if I take an odd that's 3 even, that must be congruent to 3 mod 6, because the 3 evens in mod 6 are 0 and 3, and then it loops back around, and if it's not 0, it must be the 3 one. Similarly, I can say that an even post 3 even must be congruent to 4, an odd post 3 even must be congruent to 1, an even pre-3 even must be congruent to 2, and an odd pre-3 even must be congruent to 5, and what do you know? These are one of each of the 6 numbers we would want. And we have these 6 values, and luckily we have a 1-to-1 correlation between combos of mod 2 and mod 3 and mod 6. We could make some sort of conversion chart where we see if I write 0, 0, and I know I'm saying mod 2 then mod 3, that lines up exactly with the mod 6 value. So we can describe all the mod 6 values also by thinking of them as a pair of 2 numbers, one of which can only be 0 and 1, one of which can be 0, 1, or 2. And I can't tell how bad the loading issues are because I'm always a little minute ahead of you folks. You folks see it a little later because it takes a little while for the internet to go there to have any actual hopeful quality. All right, so hopefully it's not too extremely glitchy. Now, there's also a chance that when my streams process from YouTube, that they are better quality. I'm not sure to what degree that's the case, but hopefully if we look at the processed version later, it might retain less of the glitches, although I'm not positive. So if you can hear me talking about loading, that's a good sign. But overall, yeah, it's not a good day for it for some reason. It's not liking it. And hopefully we will ride out the storm and it will go to a better state. Now, as I was noting here, we could describe combos of mod 2 and mod 3 as exactly building into mod 6. We could try and do a similar thing with turning pairs of mod 2 and mod 5 into mod 10, and that is what happens in our base. The last digits that are possible in our base are combos of whether it's even or odd and how far it is from a multiple of 5. And so the problem with that is, for 1, there's that giant hole at 3, and for 2, we don't get as neat of nicknames. So with those, we'd have to call it post feven, double post feven, pre-feven, doubly pre-feven, and feven. And let's see. Yeah, this is not working well, but I can't. It's hard for me to try and view it because it's not good on my end either. And then when I see it in my app, it looks fine. So it's hard to say. Hopefully, any of this will make sense later in a process version. Worst case scenario, I might have to quit the stream and restart somewhere else where I'm closer, like in my room. Now, assuming any of this is transmitting, we could reorder these and put in the order that mod 6 would put them. We would have 0, 0, 1, 1, 0, 2, and so on. We can also look for patterns by combining the multiplication table and the division table. Now, let's see if there's any chance that I'll be able to show my screen, which is not very likely because this might crash it out even further. But to give it a shot, we will take a look here. I had the number 6 here, but there's also a cool thing I wanted to check out about fractions, and they also have good mod tables on a similar interface here. And to look at how some of our fractions are going to behave there, let's see if this will load at all. It's not going to help things loading at first, but then I'll be done with the fraction part and we can close this thing, this part of it. So this interface lets us see a denominator and a base. And the denominator tells us the bottom of a fraction, and the base tells us what base it's telling us the decimals in. The fractions, let's see if they change how they're written. The fractions stay written in base 10, so they're giving us just a standardized thing we do recognize. And they're showing all of the ones between 1 and the rest of the integers up to the fraction number. Not including the fraction number itself, because that would equal 1. And they're using letters like A's and B's and stuff if we were in a further base for what digit symbol we would use for 10s and 11s and stuff. Now, looking at the multiplication tables of Mod 6, I've already shown in a few episodes, so I might not need to draw the whole multiplication table for it. There have been at least 1 or 2 times that's come up in a video. But the fractions we haven't spent too much time comparing. Looking at, in base 10, looking at all the small denominators, it's good at doing 1/2. It's pretty bad at doing thirds. It needs a infinite amount, although luckily the period is just 1. So it's infinitely repeating, but with a period of just 1 at least. And then if we go to fourths, those aren't too bad. Go to fifths, not too bad. Sixths, pretty bad. You got a digit and then the infinite repeating 1 on some of these. And sevenths, super wacky. You got a 6, wait, where's sevenths? You got a 6-digit repeating string. Not very good at doing that. 6 digits repeating in a cool cyclical way. We can see 142857 in all these, 142857, 142857, starting at different points. But it's very confusing as far as simplicity for your base. We'd get other cool numbers like this. Don't worry, this relates to something called cyclic numbers. Now, what if we were in, say, base 12? That's a common alternatively suggested base to base 10. Well, if we go down there, halves, good. Oops, thirds, good. Off to a great start. Fourths, good. We're doing awesome. Fifths, not great. Sixths, good. Sevenths, not great. So, base 12, the most commonly suggested alternative, is not very good at sevenths either, and it's better at thirds instead of being better at fifths, which is better than base 10, but maybe base 6 can get us past and get even better. Base 6, if we go down to the start, halves, good. Oops. Thirds, good. Fourths, pretty good. Fifths, not that bad. It's repeating, but it's just 1 digit. Sixths, that's the base itself. Of course, those are good. Sevenths, not that bad. 2 digits repeating. There base 12 was far worse for fifths and sevenths. Base 10 was pretty, it wasn't as good at thirds. It was similar looking to how base 6 looks with fifths, how our base looks with ninths and thirds. So a one-digit repeating string as everything there. So base 6 has way neater fractions all the way up through the first 7. Those would be really easy to remember. You practically give up on trying to learn fractions because of 1/7. And even things like 1/8, although it doesn't repeat, you need to remember 3 digits, 0.125. 1/9 does repeat like 1/3. They're simple repeats, so you might be able to remember 9th, 6th, and 3rd. 6th, people often forget the fraction because it has a different digit before the repeating bit. But in base 6, we probably would have had all these memorized in school. It'd be easier. That one's just a digit. That one's just a digit. That one's just 2 digits, kind of like a fourth is in our base. This one would be like how we think of thirds, although technically it's more similar to ninths. In fact, let's notice a pattern. Denominator 5 in base 6. Denominator 9 in base 10. Very similar looking. That's because if we ever have the denominator be 1 less than the base, we're going to get this type of thing. And in all of these cases, the last one makes sense to be, in this case, well, there's a version of this in all of them, but it's easier to explain just in base 10. In base 10 here, we can see this leads to the logical fact that 9/9 does equal point infinite nines. And everyone who brings up infinitesimals, those do not exist in the real numbers. A lot of people who haven't actually studied them that much once heard that there are fields of math where infinitesimal numbers exist that are similar to like 1 divided by infinity in an oversimplified way and could get you infinitely close to 1 without being there. Those do not exist in the real numbers, which are the system that all these fractions are happening in. So unless you want to, stop using all of your typical rules of addition and multiplication and re-clarify which of them still hold, you can't just throw in infinitesimals. They do not exist in the real numbers. And in the real numbers, in decimals, 9/9 equals point infinite nines. And 9/9 we know equals 1. So this is an interesting way to see a gut feeling for that, but also just nice to remember that this similar thing will happen in any base where the denominator that's 1 less than it, like in base 6, we saw it for fifths, where in base 6, point infinite 5, if we counted in base 6, the big debate would be, does 0 point infinite 5s equal 1? Because that would be the highest digit in that base. And in that base, point infinite 5s is another way of writing 1. So I will do a more thorough explanation of that in an episode at some point, because it's not quite as simple as some people think to prove. A lot of the proofs for it are really good logic for why it's true, good examples of it being true, but you can't really do a really simple proof that doesn't already make assumptions about things. So we have to sort of go from a more ground level, like, what symbols do we allow? What does it even mean to allow a symbol? Why would we allow a symbol? We don't allow every symbol, so if we're allowing infinite of a thing past the decimal point, what rules should it follow? We don't allow infinite of a number to the other side of the decimal point. Some people jump to the fact where it's true that in the real numbers and in base 10, point infinite nines equals 1. Some people then butcher the explanation by saying, it must, point infinite nines is a real thing in the universe that equals 1. And it's like, no, these are symbols humans created. The point is that in all of the systems that work well, that are consistent, we want that to be true to fit the consistency. Not that these are, it's more than symbols. It all relies on what base we count and stuff. It's notation. And we don't allow infinite digits to the other side. So when I make an episode about that, we're going to have to go from scratch and look at why did we allow infinite digits to this side? And then what should we follow? And that's sort of what I mean about in a good episode, and it's why it takes me sometimes longer or shorter to script a topic, depending on when I get to this point. I try and tell a little story where we try and get to the end. And sometimes those stories will relate to why do we have a system? What's our goal? That is similarly some stuff that happened in the newest episode on the main Combo Class channel that you should all check out. I think the viewers have been enjoying it so far. It's a return to pure math after a few somewhat more philosophical ones as we switched grades. Now, I have no idea how well our glitchiness has been working, so what I'm going to do is close out that guy, try and take a peek at our glitchiness status, and hopefully some of that came through. I'm not sure if any or much of it did. Now, somebody's asking if infinity is a number or a concept, and, well, infinity at heart is a concept, but it's often good to say, can we turn this concept into something number-like? And we can turn infinity into number-like things. However, there's a few types. Infinity exists as limits of things, which essentially mean an action continued indefinitely. So infinity often means infinitely long has occurred, almost. And so infinity can mean indefinite in the form of a limit, meaning beyond anything finite. And typically it means that type of thing, which is sometimes clarified in a different way and called arbitrarily large, is a somewhat similar concept, refers to something larger than any finite number you could pick. But an arbitrarily large thing doesn't have to be infinity. For example, there's no prime that's infinitely big on its own. That doesn't make sense. But there's a prime. There are arbitrarily large primes. There are primes larger than any finite size. Primes essentially approaching infinity as a size, but you wouldn't say any of them are infinitely long. And so arbitrarily large is another connected concept. Infinity has other ways it'll show up in numbers, and so it has, in fact, many ways it can show up in math that you have to be careful when you're clarifying it, which one you're talking about. And another one is you can actually try and turn it into a number, but then it doesn't make sense just to have one number on infinity. To have a logically consistent system, you want multiple infinities, and there's a hierarchy of them that there's still questions about. And so you can look at things called transfinite numbers and the large cardinals and numbers that are considered to have a size larger than any finite number. But infinity can mean different things, so it can be used as numbers, but it's good if you ever do to clarify which of those or a different one you mean, because otherwise people will, similar to how I said, whip out infinitesimals to try and disprove stuff when really the infinitesimals don't coexist with the system that they usually use, and they have never specified that we have left that system. Similarly, infinity is like that. Infinity doesn't exist as a number in the real numbers, for sure. And so if we ever mention infinity, we sort of want to automatically, we're sort of on the spot to clarify why we brought infinity in and what we really mean by it, so that it does make sense. Because otherwise we'd assume if I talk about a number that I mean some finite size real number, and it's not one of those. So we will in fact do more episodes about types of infinities and other ways infinity shows up. There are even times where you can, when writing an integer sequence, write an infinity symbol for one of the terms because it makes sense in a weird way, such as if we write how many regular polytopes can exist in different dimensions, or convex regular polytopes, I'll do right here. The amount of convex regular polytopes of different type that can exist in different dimensions are, there is 1 in the first dimension, there's an infinite amount in the second dimension, there are 5 in the third dimension, 6, and then 3, 3, 3. Now, I made an episode on the main combo class channel about how I think it's fun that this includes 2 types of infinity. So there's actually 2 types of infinity going on here. There's one where I put an infinity sign to mean there's an endless amount right there. And then there's an infinite amount of something where I didn't write an infinity sign, but where there is an infinite amount on this scale of something. So you got 2 types of infinity in there. It's pretty neat. Now, infinity is fun to ponder because it's not just a number. Of course, it also is a concept. And I believe that there are one way that we will certainly look at infinities in the future that I think relates to life and I think relates to other things than just geometry, although I'm going to describe it geometrically. I think it relates to more than that, is when you are looking at a sphere, if you chop it into cross sections, there's an infinite amount of 2D circular cross sections, and it has a finite volume, but an infinite amount of areas you could slice it into. Each of those areas has a finite area, an infinitesimal amount of volume, and an infinite amount of lines you could draw across it that would each have distance. And so from a given dimension, you sort of have a finite amount of your dimensions quality that you're looking at, and an infinitesimal amount of higher dimensions, and an infinite amount of lower dimensions, and or an infinite amount of quantity in each lower dimension. And so I think that we'll come back to that to explain like hyperspheres, hypertetrahedrons, and cubes and such, and how I think those could relate to some interesting philosophical things, as well as other math concepts where, depending sort of what scale you're at, you can be at different sorts of infinity. You can even see a different version of that, I realized, in calculus, where depending what level of derivative or integral you're at, you may be describing an infinite, finite, or infinitieth amount of a thing. And so that's interesting, and we'll get back more into that in the future. Someone said there were no glitches when I was on the website. I think that was coincidental that it was when I was on the website, but good to know. Maybe there's a chance it doesn't like my face being big and it prefers the screen being big, so we could try that. We could try me being on 6 and see if my face being small gives the computer an easier time loading it. So, and infinity is in many ways the flip of 0, but it's 0 is, in terms of addition, its own flip. And so infinity has traits of the multiplicative flip of 0, but so would whatever you describe negative infinity as, whatever the negative numbers are approaching. And so both of those have traits of being the flip of the number 0. And so as you approach 0 multiplicatively, you ramp up a weird hill of fractions that is reminiscent of ramping toward infinity. And in fact, it's very similar, the 2 different things I just discussed about first how infinitesimals don't exist in the real numbers, then how infinity as a number doesn't. They're for very similar reasons, where as you ramp up towards 0 multiplicatively in fractions, or you ramp up that way in non-fractions, you never reach a certain thing. There's an endless amount of a certain thing. So that's pretty neat. There's also different sizes of infinity you can compare types of numbers to. And something I mentioned before but I haven't done an episode fully explaining yet is I did one about and that was probably confusing when I had that open because you're probably seeing two different layers of the stream. That's what I mean by we're at different times. But I haven't done an episode explaining this yet, but basically in terms of infinities, there are ways to describe how many of a type of number there are, and one that you can actually use to describe stuff is this one called natural density that I've done, and there are other ways that say what's the rate things have been occurring at for a type of number. But then there's also ones where types of number, if you just look at how many there are, without the rate they're occurring, how many are there, you'd want to say there's an infinite amount of square numbers, an infinite amount of fractions, an infinite amount of total real numbers. But at some point there, you cross a line where you've gone from what's nicknamed countable infinity to what's nicknamed uncountable infinity, as far as two different types of it. There's not just two infinities, but going from a countable to an uncountable, which is nicknames for a next level of infinity that you can't create what's called a bijection between. We'll explain that more in the future, but essentially you can find a way of mapping the whole numbers to every fraction as a one-to-one thing, but you can't find a way to map the whole numbers or the fractions to every real number as a one-to-one thing. So it's a deeper type of infinity. So we'll definitely have to explain that more in some episodes in the future. And for now, we will look at a few fun traits of the number 6 on here that, even though we've looked at this article before, we just need a little reminder of how classically underrated this number is. Look at all these types of number it is, and many of them, you even get things they didn't mention on this list. This list could be way longer, of traits that 6 is the only number to do. Let me think of a few I can think of just on my own, which are, you can have 6 is the only number that is the same factorial and the same triangular number, the sum of the first amount of numbers and the product of those, apart from the number 1 itself, if you even count that. And 6 is it's the largest number that's a factorial and primorial, where it's the product of primes as well. It's the largest highly composite primorial. It's the largest number divisible by its digit sum in every base. It's many other things that it's like the largest, which is just meaning that there's a few others below it, that there's only a few numbers that have the trait and 6 is the biggest, or ones where it is the only to do it, or some where it's the only non-1 number to do it. In any case, small numbers do cool stuff, but people forget that 6 actually is like in the mix of those small numbers that does really cool stuff. Arguably the largest of the numbers to do that much cool stuff, and also arguably in ways does more cool stuff than the number 5, which does its own deal of cool stuff. 5 is, the first prime that's not sandwiched right neighboring another prime. 5 is the only prime that's in 2 twin prime pairs. 5 is where the insolvability of the quintic makes certain polynomials weird. And 5 does cool stuff, but I don't know if as much as 6. Same with 4. I don't know if 4 does as much cool stuff as 6. So, although 4, should get a lot of credit, being the first, you could say, non-trivial square number. Sorry to 1, it's going to get the name trivial a lot because it's a member of too many families. That's, shouldn't be taken as a diss to 1 that we have to call it trivial. Sometimes it means this thing's in like every family. Sometimes we got to ignore it. This, even when you have a trait that usually only one number fits, sometimes one sneaks in two. So 6 also, as I mentioned the other day, is a neighbor of every prime except for the primes that make it up. 2 and 3 are the only primes that are not right next to a multiple of 6. I don't mean the number 6, I mean a multiple of 6. But every prime is either 1 below a multiple of 6 or 1 above. And we can see why with our chart here. 1 above a multiple of 6 or 1 below are the ones that are, say, 5 here. And I know this is kind of small. I'll get a tiny bit bigger for a sec. The ones that say 1 and 5 line up with 1, 1. Okay, I'm odd and I'm throd. That's a good sign for a prime. 5 lines up with, okay, I'm odd and I'm still the other type of throd. It's another good sign. Those are possible to be primes. All these other ones are either even or threeven. They either have a 0 there or a 0 there. The only ones that have a 0 in neither 2 nor 3 are the ones that turned into 1 in mod 6 and the ones that turned into 5 in mod 6. And so those are the only spots primes can hang out. And the ones that break the rule are 2 and 3, the numbers that make up 6. And in fact, that leads to part of why 6 is such a great base. And it's part of why the fractions of 1/5 and 1/7 were not that sloppy in base 6 when we saw that. And it's why in base 6, multiples of 5 and 7 would actually be kind of easy to find the multiples of. In fact, you wouldn't really have a hard number to test multiples of in base 6 until like 10, 10 or 11. I would have to check what the divisibility rules for those were. Whereas our base, as I showed in a recent episode on this channel, has a hard one for 7. It's not good at that. And so the reason for all that is because 6 is made up of the first 2 primes, and the next 2 primes are, if we call 6b for the base, b minus 1 and b plus 1. I've mentioned before how the b minus 1 number in a base makes its divisibility properties really neat and cool. That's why 9 in our system does a lot of cool stuff. And so 5 would be doing all that cool stuff that 9's been doing if we were in base 6. 7 would be doing all the cool stuff that 11 is currently doing, because 7 would look like 1, 1 in base 6. Then you get a few more numbers that go after 7. You get a cube of one of the factors of the base, a square of one of the factors of the base. One of the factors times b minus 1, that's a medium good, and then another prime. So once you get up to 10 and 11, it might be a little harder to test multiples or stuff, but you're good all the way up through there. Imagine if the size of the times table that you normally learned was just way easier. And that size would be describing the same amount of numbers, so the same size of stuff, but it would just be now looking like it's writing up through 1, 3 times 1, 3 or something. So base 6 will do multiplication tables in it in some episode. As we saw, the fractions can be neater, and a lot of those properties are because in the low numbers, your primes are 2, 3, 5, 7. And then you go up until the next prime's 11. And apart from getting all the way up there at 11, all of the other numbers are either one of those 4 primes or have a factor 5 or less. Like have a factor of one of, even entirely composed of their factors out of the lower 3 of those primes. Like basically, if you go up the number line, we see we've gotten the unit. Prime, prime, square of the first prime, prime, first 2 primes multiplied together, next prime, cube of the first prime, square of the second prime, And then we get to 10, where we had first prime times third prime, starting to get a little weirder. And all the way up through there, base 6 would be great at handling stuff because it's made of the 2s and 3s that made 4, 8, and 9, and 6. And what's left over? 5 and 7, the numbers that are the new 9 and 11 of the base that have really easy divisibility and multiplication stuff in comparison to other stuff. So, who's with me on base 6? We will be looking more into that at some point in the future. And that's because even though we talked about it a decent amount right now, I think at some point, due to wanting to compile some of the coolest things about the number 6, I will make an episode called something like 36 facts about, or no, 36 reasons why the number 6 is underrated. Something like that, because we can go for 6 squared amount of reasons. 36 is also a very underrated number. It's triangular and square, and the square of a triangular number, and has all these cool properties. And 36 would get its credit in base 6 because it would look like the new 100. It would be 100. So it would, be on all sorts of packaging and all sorts of ways that things are laid out in our society, and it'd be easier. So remember also that if you need a better number around the size of 100, the number 108's pretty divisible. That's a little better. There are a few in that range. You don't get a super divisible right there. Really, the best 100 is 120, the long 100. But as you go higher up, there are lookalikes that are really close to them. Like 10,080 is far better than 10,000. 1,081,080, far better than 1 million, and so on. So, taking a peek at the chat on my phone so I don't stress out the computer at all, which will take me 1 second to pull it up. Hope you all are having a nice day. Thank you for joining me here. It is on its way to getting dark, and I'm not sure if our stream will last until it's dark, but just in case it does, or we can try this out beforehand anyway. Not that this will give the computer an easier time, because the only way of plugging it into something right now is a USB type thing that I have to go in the computer. But what I'm trying to get to is I brought a cool little plasma orb out here that I showed in a short a while ago about how there's these little things called plasma orbs. And someday we'll do an episode about plasma and about how it's in a way an under-talked about element, because although it's not in large quantities on Earth, it is, I believe, the most common of the elements when you're comparing solid, liquid, gas. I mean, not elements, states of matter, sorry. The most common of the states of matter when you're going solid, liquid, gas, plasma. There are others, but if you're just ranking those, I think plasma is the most frequent when you factor in outer space. But since it's not around on Earth as much, it doesn't get talked about that much. So, let me take a look at some stuff in our comments. And let's see. Somebody is asking how they can enter a denominator of 9 in base 6 when they're playing around with that Wolfram thing. It probably translates it. It's probably saying the number 9, which still exists. And so, because the fractions, remember, were written in base 10 language. 1/9 still exists in base 6. If we translated it, it would look like 1/1/3. It would look like 1/13 if we were describing the question of denominator of the quantity 9. But remember, they translated all the fractions into our base. So, whoever's here and hates math, they are going to get a decent amount of that on my stuff. Maybe they can just space out during the math and we get to nature and crazy science experiments at other times. But, this might not be the greatest home for the number haters. However, if you are a number hater, I recommend that if you stick around, you will slowly expand and grow a love for numbers that sees them as different than whatever aspects of math you don't like. You're allowed to have aspects of math you don't like, but let's not say that all math's bad, That's some people think math is just one thing, like, some guy in a college in a suit doing arithmetic. And so when you think of that, math is something you could imagine hating all of if you weren't into that. But math is secretly so diverse that not liking all of math, people don't understand, but is similar to if you said something like, I don't like science, or I guess that's a little further because math could be seen as a type of science. But if you said, I don't like history, and you don't mean I don't like studying history, you just mean like history is used. What's the point of having history? Nobody needs history, which most people think would be a silly worldview. Most people think, oh, history is helpful and it's good to know some, even if you don't like studying everything. Not everyone has that same appreciation for math for some reason. I personally think it's even artistic enough that saying that you hate math is like saying you hate music. But that's leaning more toward personal opinions. So, but I don't mind if people leave comments saying that they hated math, because those are probably the people who are going to unsubscribe anyway, so why not leave a comment on their way out the door? So, let's see. Yeah, on the Wolfram demonstrator, it's a little weird. They're putting, it makes sense sort of, but why they would want to do this, but it is a choice of which ones they translated or not. As usual, bases are different languages from each other, and you have to decide what's your fixed point at each stage. For example, if I say, what's this in base 6? Then I'm like, well, wait, I didn't clarify enough. Do I mean, what does this symbol mean in base 6? In which case, that would refer to the quantity 9. Or do I mean, how do you write 13 of a thing in base 6? Am I assuming that this was in base 6 or that this was in base 10 as my starting point? We need some starting point to go from, and it's actually a different question that some people forget to clarify at times of, if I say, what's this in base 6? We gotta say whether I mean, this is the symbol I'm given, what quantity, or this is the quantity I'm given in the terms we know, what's the symbol? So, it is a little tricky when you try and wrap your brain around that double way it could be, but try and compare it to a language, because they are languages, and you'd imagine if you're trying to describe how to learn Spanish to someone who knows English, then you need a jumping off point at each thing. You can point at an item and say it in English, and right then you're like showing an amount and showing the symbol it would have. You could say something in Spanish and then followed by it said in English, in which case you would be like showing something how it was written in one base, then how it would be written in another base, or other ways of going about a thing. So let's remember that bases are languages. However, they are surprisingly consistent languages, unlike the humanly made word languages, which are all full of some level of inconsistencies and weirdness and problems. English more than average, full of problems. We're going to have more episodes about language over time, and typically when I go into a language episode, I'm like pulling out my hair in more frustrated mood, as opposed to like, look at the glory of life mood. Because when I look at numbers, I'm like, wow, things work so well. And when I look at the English language, I'm like, wow, this works so poorly. It's just really hard to learn and really clunky and all these redundancies. And some are funny enough that they need episodes, like how pluralization works and all of the weird exceptions to how you'd expect pluralization to go. Which words rhyme and don't rhyme, which families that creates. That'll be in episode 2. That's interesting. Someone's pointing out math as the Greek word for learning, and that being how fundamental it can be seen as. I don't know if I would have used that if I was naming a language, because maybe something like science would be for learning, because that's sometimes beyond the scope of what we describe math as. However, I think math is the closest we have to an objective truth about things, and objective truths such as I can define 2 in a sensible way where 2 plus 2 equals this other sensible to define thing 4, and it's logically consistent. Of course, it's all still language, but math is closer to objective than some things. Various sorts of science are. So somebody's wondering what's 10 in base 10 written in base 6 and base something weird. I'm not sure how that base would work. Written in base 6, 10 would be it would look like 14. 1, 4 would refer to 10 in base 6 because you have a 6 and you need 4 more. You have 1, 6, and 4 more. So that's really how you can think of the base, is if you are in the range of a 2-digit number in the base. Okay, how many of the base number do I want? How many extras do I need? And then if you need more than the base number, or if you need at least or more of the base number amount of base numbers, then you have to go outward one, and you're like, okay, how many base squareds fit in it? And then, you need to do a few calculations. So, in base 6, the symbols we will be losing are this look-alike pair of 6 and 9. No more look-alike worrying about, how when you have game pieces that could get flipped around in the bag, they have to write a line under them to clarify. No more lines needed in base 6, baby. We're not going to need those annoying lines under things to clarify which direction it's going. And 7, that one that looks too much like 1, which already looks too much like I and L. This IL17 thing has gone on too far. We're also going to be losing the one that looks like a sideways infinity symbol. Now when you see one of those things sideways, you don't have to worry if it was an 8. It was an infinity symbol. So, out of all the symbols to lose, I don't think we're going to be losing much. So, the patterns in that base are pretty neat and fun. It also just makes things easier to remember patterns of when you have fewer possible digits, especially with how neatly they're all tied together, where you have like the one after the multiple, and in the mod we'd call it congruent to 1, but like 1 after a multiple, and my first even of the round, my first 3 even of the round that's not the multiple itself, and then I get my next even, and these evens are balanced. There's the 2 and 4 are split like 1/3 of the way, 2/3 of the way. It's just like really nice to imagine visualizing your numbers. You have 0, and I'm going to write this as 10 now. Now I'm writing this in base 6. So in base 6, here we got 0 to 10. Halfway, we get 3. I know you might think it's weird that halfway we get 3, but check out this symmetry. 1/3 of the way we get 2. I think that would be kind of easy to remember. Halfway is 3, 1/3 of the way is 2. It would relate to decimals too. 1/3 is 0.2, 1/2 is 0.3. we'd be able to remember that little flip. And then we would know that 4 is twice 2. And from 0 to 4, 10, that lines up on thirds. And from 0, 6, 10, that lines up on halves. And then I get my sixths, my 1/6 and my 5/6. And those are the only spots the primes can lurk. So, in fact, something that I haven't really considered until relatively recently is that the primes really like the lower part of the number line. They're a lot denser there. And in the lower part of the numbers, we can note that not only are there the primes 2 and 3 that sneak in at this spot in the cycle without being congruent to 1 or congruent to 5, or in other words, without their last digit in base 6 ending in a 1 or 5. Basically, those would be the only primes in base 6 that didn't end in a 1 or 5. Imagine how much easier. In our base, primes end in 1, 3, 7, 9. Base 6, they just end in 1 or 5. Then, normally you think, well, it's not going to be that many primes of the ones at those possible spots that actually are prime, because this was just saying those spots aren't even or threeven. That tells us nothing about if these spots are divisible by 5, 7, 11, or anything else. And it's true that as you go up the number line, most of the numbers in base 6 that end in 1 or 5 are not prime, because at that point in the number line, there's 1/3 of the spots available, and less than 1/3 of the numbers are prime pretty soon. And, or whatever metric you want to use, you're not going to have that many 1s and 5s actually getting primes when you're far enough up the number line. They get more spread out. However, on the lower section of the number line, it is really crowded with these spots wanting primes. And we can think of that as partially because to have a composite number that wasn't even or threeven, which would be basically these 1s or 5 spots, numbers that end in the digit 1 or 5 in base 6, that we'd call congruent to those things in mod 6, are really, really filled up by the primes, because to have something there that wouldn't be prime, we know these spots are not even or threeven, and if it's not prime, that means it's composite. To have a composite number that's not even or threeven, the minimum one of those is 5 squared. Because composite needs more than one factor, and if we can't have 2 or 3 as a factor, the minimum is 5 squared. And so, if we think about it, up until 25, in the first 24 numbers, every one of these spots, apart from the first 1 here, which 1 is not considered a prime, all of the rest of the 1 and 5 spots are definitely going to be prime up through 24. And it's true. You get 5, 7, 11, 13, 17, 19, 23, and then you would get 25, and there's your 25. That's your first composite at one of those spots that sneaks in. So, some people forget, if you need to remember a prime less than 24, the primes less than 24 are 2, 3, and every single number that's either 1 less or 1 more than a multiple of 6, and nothing else, apart from the number 1, which is too small. And so, somebody asked about a Fibonacci number system, and that is possible. And base pi I briefly went into in an episode. I haven't done base Fibonacci, however you'd call that, yet. But the Fibonacci numeral system is interesting, so we will have that in some episode. Someone's also noting you can count up to 35 using your fingers. We will actually do episodes at some point on different ways to count on the fingers, because I was for fun one time brainstorming what's the maximum I could count up with different combinations. On binary with two hands, you could technically count up to 1023 just by having fingers represent ones or zeros and using 10 fingers in a row. So I've tried to play around with what is a system of using your hands that's not too convoluted, of too many ways of contorting your fingers, like you should be able to do it comfortably, that lets you count past 1023. So still working on that one. I've found some that get past there, but they're kind of convoluted on what they make your hands do. So I need to polish that up before we do that. And thank you to all the people who leave nice comments. Really appreciate it. Someone's also noting 6 is close to 2 pi. That could be maybe helpful here and there too. I don't know. Engineers can use 10 as a new approximation, or the number that would look like 10, that's 6, as an approximation for tau, 2 pi. So even beyond that, I wanted to note, what are the next primes, or what are the next possible non-primes that could be at one of these spots, that these spots aren't even or 3 even? Well, the next composites that are neither even nor 3 even would be 5 times 7 is 35, 5 times 11 is 55, and in between those, 7 times 7 is 49. So those are basically our non-primes up through that range that aren't at these spots. If I eliminate 35, then, which is 5 times 7, then I'm actually good up till 48. All of the first 48 numbers that are, all of the first 48 numbers that are 1 more or less than a multiple of 6 are either the number 1, the number 25, the number 35, or all of the primes in that range exactly, apart from 2 and 3. So it's actually kind of easy if you can figure out your nearest multiple of 6, which would be really easy in this base. But even in our base, if you are able to, with your head, somehow know where your multiples of 6 are at, it's really easy to know where the primes are at. If you just remember, we got to also include 2 and 3. We got to not include anything except for congruent to 1 or 5 in this mod. We only include ones that are 1 less or more than a multiple of 6, that aren't 1 itself. And then we additionally check off 5 times 5, 5 times 7, and 7 times 7. Well, everything on the way up to 7 times 7, and then up till you'd need to check off 5 times 11 would be good. Now, in our base, the multiples of 5 would be pretty easy to know that they weren't primes. You get an extra helper in our base, but it would be way harder to do the am I near a multiple of 6 thing. In this base, it's literally given to you at the last digit. And like I've mentioned, it's a better ratio. In our base, there are 4 possible last digits out of 10. That is a ratio where you have 2/5 of the places could have a prime. In this, only 1/3 of the places could have a prime. I think it's neater and better to have the primes more compartmentalized by last digit like that. So, somebody's also mentioning the meaning of life is 42, and I have 1 life, and Dandelion has 9 lives due to being a cat. Added up would equal 52. I'm not sure exactly what you're getting up to there. But yeah, 42, to those who don't get that reference, is a reference to a book series that I recommend. Not pure math by any means. I think a mathematician would be far more likely to enjoy it. It has a lot of mathematical concepts, but it's not a textbook or anything. A fiction book, which was The Hitchhiker's Guide to the Galaxy, and the series based around that by Douglas Adams. Actually, one of my favorite book series. Very funny. while still maintaining a deep philosophy. So each of those books is, I think that's some of the best art when you can simultaneously be funny and deep. Kind of hard to pull off, and to me, some of the best art. So I recommend reading those, at least the first couple of them, even just the first one if you're going to try something out. And, of course, I have mentioned this a while ago and at various random times, but I am working on books of my own that I've been writing for a while, both math books and fiction books. And I get pretty perfectionist with them and have them re-edited and millions of pages of brainstorms before I let myself do as much finalized text as would be useful. So they still have a while to go, even though many projects I've started already have more than a book worth of brainstorms. And that sounds like an exaggeration, but it's not. I write a lot as sort of a neurotic habit. I like putting my thoughts on the computer and paper when I'm not streaming. And so or filming or stuff. So I have an absurd amount of notes I have to go through and compile into more sectors of finished text. But I will be revealing books at some point, which will include both fiction books that hopefully you folks will enjoy, and math books that will be pretty directly along the Combo class brand and style. So, the grade -1 curriculum textbook. It's a good suggestion. However, I have so many other ideas that I'm more likely to first write a book about other ideas that aren't the ones that I have put in this grade necessarily. But if anyone else ever wants to write up some notes of it, there's a chance I will endorse it for you as a good written version. I will write versions of it at some point of the lessons, because I do own for later, although I don't have anything built on it yet, so it doesn't lead anywhere yet. I own comboclass.org for later, and so I do hope to someday have a sort of Wikipedia-esque structure in the midst of video links. So topics would hopefully have pages where I have a video and something written about it on those pages. And other fun things will be on that website as well. But that's not one of my sooner goals. My sooner goals are some fiction books I've been working on, and 2 possible math books I might start with. One which is somewhat about inventing numbers from scratch and relates to relationships of certain things I will also discuss in grade -2, such as patterns when you build numbers somewhat from scratch, not really meaning with axioms as much. Some of them will already take for granted, but meaning from scratch using just a list of ones to create the natural numbers and use rules to make those become factorials or triangular numbers or all sorts of other stuff. And it's going to also lead to polygonal numbers, which are underrated. I mean, one of them's not. You all know one polygonal number that's not underrated. Square numbers. That's going to be an episode before too long, is going to be called something like the polygonal numbers beyond square numbers. And at first, we're actually mostly going to be looking at cool patterns between triangular and square numbers. The smallest 2 types of polygonal ones, unless you count linear numbers or point numbers. And the triangular and square numbers have many cool relationships. So the first episode I do about those, which will actually include some animations, I'm working on an animator with those, will involve mostly triangular and square and a little bit of pentagonal numbers and maybe a little bit of hexagonal numbers. But those will also be returning throughout the grade and maybe in that book I mentioned, because they're very underrated and cool. Apart from the one, like I would say that mathematically, all the rest of the polygonal numbers with more than 4 sides in the polygon type are underrated by many mathematicians. Triangular numbers, I would say, are fairly rated by mathematicians, but underrated in average society. Square numbers are fairly rated. Square numbers get the proper amount of credit they should get, no more, no less. So, in general, even squares, it's not just square numbers, but that's something I believe about reality too, is that squares are fairly rated. They get a lot of credit. They're a cool shape, but we could call them comparatively overrated compared to triangles and stuff that maybe should share a little more of that credit. Or maybe hexagons. And hexagons, triangles, and squares do happen to be the only 3 regular polygons that can tessellate a plane like a wallpaper tiling, leaving no gaps. So, for example, you cannot put pentagons side by side and not have gaps. Funny enough, the shapes that can wrap around as the faces of fair dice are triangles and squares. Triangles and squares have enough room to wrap around and make fair dice, but triangles can make more types. Triangles are the faces of more types. And by fair dice, I mean, beyond just them playing fair, I mean, the type of shape you would associate with a die being the platonic solids especially. Triangles and squares can wrap around into a convex regular polytope. But, that's funny. So, I think I got an ad while I was watching my stream on my phone. I'm not sure. Can people in the chat let me know if you get ads in the middle of my stream or not? Because sometimes I'm allowed to pick when there's ads, and other times YouTube just puts in the ad anyway. And by me not picking, I guess I meant, oh, don't worry about paying me for the ad. Because I purposefully don't have ads in the middle of my streams. I have ads at the beginning because, I need a budget for combo class to come from some places, but I don't want to disrupt the flow of the stream, so I didn't put ads in the middle. But if people are getting them anyway, I'm going to check that box because I might as well have YouTube pay me for the ads if they're putting them in. So let me know. Otherwise, maybe I just saw one for some weird reason because my phone loaded or something. But that was something annoying I realized at first, is that you don't have, before I was in the partner program, I wasn't getting paid on ads, but YouTube puts them on the videos. So when you get an ad on the video, it's not always the creator's choice. Some ads I do choose to put on videos because I need to make money somewhere, and I think it's better than a sponsorship in the video. I think most people would prefer the ad at the beginning that's a separate little thing you click past than part of the video being a sponsorship. But I still try not to overload them with ads because I don't want them to be annoying. Okay, maybe it was because it froze. Okay, possibly that, someone says. And some people do have ad block, so I totally understand. On some of my browsers, I may or may not use that as well. So that does save you a lot of time. Do remember to all the ad blockers out there, if you are a really big fan of combo class, to maybe consider slightly more than the average person supporting something like the Patreon, because it does help to have a budget for the show, and when people get the ads, it actually does help on my end if they're getting the ads that I intentionally put there. Not that I blame anyone for ad blocking. Ad blocking makes your life easier. Trust me, I get it. But just saying, this will be my one shout out of the episode to note we do have a cool Patreon that some awesome supporters help out on. So somebody's mentioning that triangles, squares, and hexagons are pretty strong structures. And they're strong partially because they can tile, and so they can bear weight in different ways. If you had a lattice of pentagons and you applied a bunch of weight, they would buckle and shift and stuff. But if you had a lattice of hexagons and you applied weight, they might sort of form into the pattern where they're sort of locked. And so that can be good at making weight-bearing structures. Hexagons have an interesting tiling where they meet 3 per corner, and the hexagonal grid we can look up. Actually, no, I don't want to. I don't want to Google stuff on this browser while I have it open. I want to set it up first because it's annoying that sometimes like having weird stuff related to my Google or whatever. I'm bad with technology, so to play it safe better than sorry, I'll pull up hexagonal grid and make sure I don't pull up anything else on my computer. So here we can see a hexagonal grid, and it's sort of interesting because it doesn't lay flat. Like a square grid has like a line you could draw through it like that. A hexagonal grid doesn't have like one line you could draw straight that keeps going through it. They have to stack in this weird triple way. Now we can also imagine a hexagonal grid on a triangular grid. Let's see, do they have a link to that down here? Triangular grid. Yes. Because let's look at this. You can imagine hexagons here. And when you look at a hexagon popping out at the eyes, it's easier to see a bunch of overlapping different hexagons. But if you try to imagine painting a hexagon one color, then painting another hexagon another color and trying to actually line them next to each other, you'd end up with the hexagonal grid. I'd have like one hexagon here, one hexagon here, one hexagon here, and so on. So in a way, I do think triangles are like secretly doing a lot of the coolness that makes hexagons cool. So triangles should get some of that credit. They're sort of in there all along. Similarly, all hexagonal numbers, when we go into polygonal numbers, all hexagonal numbers are a subset of the triangular numbers. Interestingly, it's the only type of polygonal number that is fully a subset of another type of polygonal number, unless you count the linear numbers, which are a weird way of viewing the natural numbers. And so linear literally meaning like a line as the polygon you're making. We are going to put in the like line numbers, or as I'm calling them, linear numbers here, and the point numbers that stay a point no matter what iteration you get into when we do the episode, because then it'll show the context of how triangles are third, squares are fourth. But normally when we do our further analyses, we will not need to be using those as much as we will be needing to use the later ones. So, someone mentioned a honeycomb grid. Too bad this is in my room and not out here. I didn't put it out here because it's been super windy and raining and I was worried it would get crushed. I should have used this in today's stream. I have that. I showed it in an earlier stream, so it already is in one of my earlier streams. Somebody mailed me a wasp nest at my mailbox, not with living wasps in it, a dried up one. So pretty cool. And it's hexagonal. It, as you look at the outside of it, because the bees wanted a shape that packed together and tessellated the grid. And what do hexagons have that win? What trait do they have out of these three tessellations that wins? If you wanted a certain trait that the hexagonal grid has the most on. I'll give you folks 10 seconds to think about it. What trait does this maximize? And the answer, I'm just giving a second because I think it's a good brain exercise. The trait it maximizes is hexagons, compared to the other ones, have the largest area compared to surface area amount. They are closer to a circle, and so they have a particular, if you wanted to pack honey, you would want your honey to be almost circular. Circles are the shape with a given area with the least perimeter. What if we wanted a shape with the given area with the least perimeter out of the shapes that can tessellate? Bam. So, that is why. And yep, it looks like we did have a comment that hexagon's close to circle, which is most of that answer. And part of what they want from a circle is they want to pack they want more honey to barrier ratio. They want, for however much barrier they have to make, a good amount of honey. So hexagons are cool, and this does relate, unfortunately, to why they cannot wrap around to make dice in the same way that squares can make cubes, or pentagons can make dodecahedrons, or triangles can make a few different shapes. And it's because we need three faces to exist if we're in the third dimension. We need to be able to specify three different things in relation to some corner. But at each of these corners, three things meeting takes up all 360 degrees, or the full amount of radians in a rotation. However, whatever term you use, it takes up a circle's amount of rotation. And so that used up all the room. We didn't have any extra room to fold around. I explained this a bit in my episode called the hyperdice sequence, which, funny enough, is the same one that Wacky Equation comes up in on the main combo class channel, where I will have another episode out next weekend. Another cool mathy one, and make sure you've checked out the prime factorization one. Additionally, I will, as usual, have various bonus content on this channel this week in the meantime, and that'll include an extra short that I filmed a few days ago and didn't post yet, and some more bonus videos. So, I'm going to wrap up our stream on the sooner end, so feel free to let me know if you have any particular thoughts or questions while we're here. There is going to be at least one more activity, and that activity is going to be lighting up my plasma orb, which I did show on a short here, but these are pretty cool. In fact, the fact that I was able to get this for an affordable amount is one of the cooler uses of modern technology. And, of course, I mean, modern technology can also save lives and such, but one of the cooler uses of modern technology for a fun purpose. Similar to how I like that they can make bubble machines affordable now. Someone said there are ads in the stream, which... and someone said they turned off ad block, and if you did turn it off just for my channel, I do appreciate that, whether it's to test it or to go through the ads. Don't worry if you do have it on. I understand, the most helpful thing, I care more about more people seeing it than having a larger budget. So it's most helpful to leave comments. Those help in the algorithm, and to watch the whole thing. Watch time and comments are the most helpful. But watching through an ad it's a cherry on the cake. It helps a bit too. To people who are getting them though, I guess this is a bad day to test it because I haven't set up an Ethernet thing yet. I'm going to try and see if I can get that going in the future. And if I can set up an Ethernet thing, then we could be sure if it's just my stream loading or not. Because there's a chance that my stream glitched for a minute and YouTube's like, oh no, what do I show? Better show an ad. I don't know. So I do know I didn't click the button that says enable mid-roll ads for this. I did not. So hopefully it's a loading thing. I'll try with an Ethernet later. We'll rerun the experiment. So I'm going to plug in my plasma orb in a minute. And I also want to make a little note while I'm streaming that sometimes on Mondays we do a weekly puzzle series. And I'll be adding the next new puzzle, which will probably be contributed by the Magic Fellow again, who is one of my main Discord mods and helps out with combo class in various ways, like has animated stuff before. And the new puzzle will be coming in my next stream, but while I remember, just in case I forget or don't have it accessible next time, I would like to add a shout out to one person who posted in the Discord and got last week's puzzle first as far as posting an answer there. To get this sort of shout out, it is something for people who are on the Discord, who are in the puzzle thread there and post it first. But the puzzles are fun for people anyways at times. But additional shout out to Potato for to win. Potato, numeral 4, and DAWIN. So Potato for to win did a good job on that one, I believe. And next stream I'll add a new puzzle as well. For now, what we're going to do is check out a little bit of interesting plasma. Now, when I showed this to a friend the other day, they asked a good question. What is in here right now? What sort of gas? And when we looked it up, let me look it up again. Because it creates an electrical current of sorts, but to make it turn into plasma, it wouldn't do that if this thing was just full of air, I don't think. And let me take a look here as a reminder. I'm not an expert in plasma orbs, but according to Google, it is a coil of wires with electrons going through them oscillating at a very high frequency. It is a miniature Tesla coil, essentially. So to those who have heard of a Tesla coil, made by the scientist Nikolai Tesla long ago, not the company that randomly named themselves after that old scientist. And there is the plasma globe. It has a high voltage electrode inside various noble gases. So it has most commonly neon, sometimes argon, xenon, or krypton. Don't let Superman near this. It has some krypton in it. Or wait, no, that was kryptonite. Huh. Is kryptonite derived from krypton? I don't know the lore. But in any case, I guess this means you probably shouldn't smash this and breathe it in because it has noble gases in it. Those are not, you know, our normal mix of oxygen, nitrogen, and such. Now, as for what this does, the plasma looks really cool. Apparently, do not copy this. I have not looked up the safety or lack of safety of this. This is just something I heard. Before you try what I'm about to say, wait until I do an episode about it, and I will say in the episode the degree to which you should never copy me, be careful if you copy it or what. But I don't know yet if it's safe or not, but apparently if you cut grapes or similar fruits in half and put them in the microwave, and microwave cut in half grapes, touching in a certain way, you can make plasma in the microwave. So, once again, do not test. I will, at some point, look up the safety and probably put it in an episode. Now, as for this, which is a very safe, contained little plasma orb, this makes me want to get a bigger one, because this thing was affordable. If I ever have a big enough budget for combo class, we're going to get a massive one of these. And it, apparently, according to Google, I guess, the bigger they get, you just start calling them Tesla coils. It's just, the smaller they are, you call them plasma orbs. So, I think it's almost dark enough to do this. I will wrap up the rest of my chatting and have this be the very last thing we do here, because the darker it is out, the better it'll be. So, last questions or comments. Thank you to everyone who is joining and appreciating, and as usual, sorry for the weird internet stuff. I'm not a technology guy. I live out here in the combo classroom. As you can expect, this wouldn't necessarily be the zone with the highest quality internet setup already. But we'll get that going in the future because I do want to make a good experience for my viewers. I actually have some Ethernet. I have to figure out how I'm going to be able to get the Ethernet going to the modem without messing it up for the other people in the house. I'm not the only person using the modem, so I can't just like take the modem. I need to figure out a way to cooperate and get an Ethernet in the mix. And I do have the cables themselves, though, the Ethernet cables coming in the mail, I believe. and some more cool science stuff like that, either gear or fun stuff, coming next time I check the mailbox, which some of the streams I said we'll have mailbox stuff that I get to show you folks, and sometimes may even semi-open on camera. I'm not positive what's going to be in them, or if it's going to contain too personal of info or whatever, so I'll probably open them like right off table or something, but I will show you new cool stuff that comes to my private mailbox, where, as a reminder, the link is in the description here. If you want to send any of your old clocks or dice or anything like that, even if you don't have anything new to send, that's actually a very cool, less expected thing, is that one of my Patreon supporters also sent me a bunch of cool science gear for us to have here. George Carosi, super cool. And additionally, it is for people to send old clocks and stuff. Its purpose that may suit more people around, because I think there are more people who are supporting my Patreon that have mailed anything, because it takes time and effort to mail something. But, it doesn't take that much money to mail something, so if you have a little time and effort and enough money for shipping and an old clock, you could get to see your clock show up in the background. I will only be checking that private mailbox because it's not that close to my house. The one that was close wouldn't accept all types of mail, so this one can, but it's far enough that I'm only going to go there like every other week or something, but I will be going this week because I got some messages that some stuff came there. So at some point this week, I will be popping by there, and so probably our next stream will involve whatever new stuff arrives, such as this Galton board we have here. This was not from the mail, but this reminded me of some of this stuff. And the tensegrity table we built, which is in my room. I need to bring it back out here. Some special mirrored glasses and stuff like that. And additionally, that beehive wasp nest I mentioned that I got mailed was also from that mailbox. Now, helium, somebody mentioned, and I do want to do an episode about helium. It's very interesting, actually, how helium can escape the atmosphere. And there's actually possibilities that there will be a future where helium is scarce. And it makes me imagine instantly, like, a scenario where you go to a birthday party in the year 4000, and maybe the year 20,000, I don't know. And they have a balloon, and you're like, or like 3 balloons, and you're like, oh my God, this is fancy. And it would just be a luxurious display of wealth, because helium could get more scarce over time. You can make it, but it takes a really long time if you want to make it the normal way. Like a really long time, like in terms of Earth amounts of time, not person amount of time. So maybe we will accidentally let all the helium out. Who knows? Now, someone said a ghost would be an ectoplasma. That is possibly a similar word root. Good gag, and I wonder, plasm, I guess, is a suffix of certain things that probably relates to plasma. To note, people have what's called plasma in their blood. That is not this type of plasma. The type of thing called blood plasma is not this state of matter. So, different use of the word. So, if you go to the doctor and they say, oh boy, you have the other type of you have the right amount of plasma in your blood, but it's the other type. You got the wrong type, buddy. It's a bad sign. So, hydrogen balloons. Yeah, I think I've seen a few videos of those exploding when they go near candles to know that that's a good idea. Yeah, hydrogen's really flammable, so we might not want to go with that right away, but maybe we'll do a hydrogen balloon once in combo class on a very safe day when I wear both lab coats and my safety goggles. Oh, and is ectoplasm just from Ghostbusters? It's such a, I think it's become almost a cultural ghost-related word, but I'm not super surprised because that is a cultural, somewhat staple of a movie. I remember seeing it a long time ago. It's probably, a good movie. I don't remember it that well. I don't watch that many movies, but I'll say it was probably a pretty good one. So, and yes, hydrogen balloon does sound fun. The fact that it can float and explode, that does not mean we should do it. But someday we'll look up the possibility of doing it. People see me do kind of dangerous stuff in combo class here and there, but sometimes it looks more dangerous than it is because, like, when I'm using fire, I have a hose ready to go right there that the camera person has. When when stuff shatters, I only have my really heavy clocks hanging lower, so I'm not gonna have a really heavy clock fall from more than 5 feet, and unless except on a special occasion. But the stuff that looks dangerous in combo class episodes is, for the most part, surprisingly safe, but that's especially why you shouldn't copy it, because you could copy it without the safety precautions. And so do not copy any fire-related stuff or any glass-related stuff or tools or whatever. And the only time I hurt myself this grade, arguably, there was a bunch of times I scratched myself or got bumped by a clock or something. But the only time I cut myself enough that I was like, I wonder if there's a chance I would have to check on the doctor on this, but then it healed fine on its own pretty quick, was when I scraped a leg a bit and bled a tiny bit by stepping on the old desk when it was completely flipped and almost pretty much all broken and really waterlogged. So it was all soaked and wet. And I stepped on part of the wet wood and my foot went just and went right through the wood, and a metal nail hit me on the way. Not the sharp end of the nail, the back of it, but it's still metal. And so that was a moment that what I was doing didn't look that dangerous. I just leaned on this table that was on the side. It wasn't, I didn't intend for it to snap right then in that way. And so, that was one of the less dangerous looking things was the time I cut myself, and all of the fire has not hurt me yet. I do it safely. So, there has been a bit of chaos. I've gotten hit by clocks and stuff, got to be careful out here. I've accidentally cut myself on broken glass that's been somewhere it shouldn't. But minor stuff. We've kept it safe in grade -1. Success! This kind of was an experiment, grade -1, that I've now decided we are going to continue a similar experiment for grade -2, and that I don't need to change that many variables in my experiment for grade -2 compared to grade -1, because although I want to upgrade certain things and there are things I do want to improve, grade -1 did better than I hoped. This channel, I didn't expect this channel to pass 100,000, or that I would be already getting put on lists along with other math channels I watch, like I showed last stream, or that even that the other channel would have so many diehard people on it. I didn't expect there would be a Discord with that many people at the point that we're just at the beginning-ish of grade -2. So things are going even faster and cooler than I would have hoped, meaning that grade -2's experiment will be very similar with just, mild upgrades. And as for what is grade -1 and grade -2, those are sort of the eras of this, which my main channel that I started first is a channel called Combo Class on here. It has a lot fewer subscribers than here, but they're more diehard subscribers. More of them watch all the videos, so probably equal power in terms of the channel's subscriber bases. But there's more subscribers here. But that's my channel that my full finished perfectionist episodes go, that are the pieces of art and lessons I want to put out into the world. This channel is more my bonus content. It just has more content and it has the shorts, so it's gone further. But on that channel, grade sort of can be seen as season of TV show. The first sort of long season I did for grade -1, but there were 36 episodes. So you can see it as a 36 episode TV show. It's an educational show, but it does have some continuity. You can see things evolve through it. I even purposefully leave things in the background that are in evolved states that we had seen something happen to them earlier. I leave little clues, little bits of lore, little recurrences. So you can see it as a TV show in a way. And of course, a lot of people just watch the individual episodes, but I think you get a better experience if you view it that way. And I make that as a fan of TV shows who hasn't really seen a math-based thing try that yet. I like having running gags. I like having fresh starts at the beginning of seasons sometimes, where you have some new tropes of the season, but also your old ones mixed in. Running gags, things like that. Haven't really seen a science channel try that format before, and so that's kind of how I see it, and those are things I like, are science. Oh, a cat's right here. Hi, Sage. Are you helping to stream? Oh, you're so helpful. That's a good helpful Sage. You came on the table to help. So, well, I guess it's a desk technically. Came on your desk, Sage. Come here. That's a good boy. He likes helping when I'm doing stuff like this. So, but Sage, you're completely blocking the view. Come to the other part, Sage. Come here. Sage, do you want to see a plasma orb? Sage. Sage, do you want to see something really weird? Sage, look. Sage, what's this? Sage, what's this? He's sniffing it. He's like, what is this? Sage, look, if you put your paw on it, it goes to your paw. Sage. Sage, boo. That's a good boy. Come here. Do you want to try putting your paw on it, Sage? Look. Okay, in any case, I had to turn on the plasma orb because I wanted to see if Sage liked it. He was kind of bored by it, actually. So that's pretty cool, isn't it? It tracks to your fingers safely. So, but yeah, the grade also resembles, since this channel I have so much fun on also, and this is like Domotro's playground channel, then the grade also can be seen as an era. You know, it's an era of life for me, it's in terms of my life, but maybe some of you have your own memories of where you were at when grade -1 came out. So maybe everyone has their own personal extra details. Maybe some people have their own lore of grade -1 was the one I watched after school while I ate peanut butter sandwiches or whatever. So this is pretty cool. Let's get a slightly closer view of it. And Sage the cat has left, but maybe he'll return in a bit. It's kind of hard to see him anyway. I think you got a little cat meow. And grades will probably be approximately 1 year, maybe not exactly. Grade -1 was being filmed. All of the content was started being filmed a little more than a year before the grade wrapped up, and started being released a little less than a year. So by release date, grade -1 was about 11 months. By filming date, it was maybe 13 or 14 months, because there's a few months where I had filmed just a few episodes for the main combo class channel, and then had to get these surgeries from last year, or I had to get the first of the surgeries, and at that point I'd just filmed a few. So it was a little more than a year that I filmed it, but a little less than a year that it came out, which this one I'm releasing as soon as I started filming it, essentially, for the new grade. So it'll probably be about a year. My guess is grade -3 will probably start. This is not by any means like more than 50% this will happen, but if I had to guess just what I thought was most likely out of all the possible dates, which is the most plausible date for grade -3 to start, I'm going to say April Fool's Day next year, because that's about a year from now. However, there could also be a break between some grades. Some people were like, dude, take a break. You don't burn out and stress out your mental health or something. And I had to tell people, I'm like, guys, trust me, I have plenty of mental health issues. I'm not saying my mental health is perfect or even great necessarily, but it does pretty good when I'm working on combo class. I highly enjoy doing this. I highly enjoy making the videos and the live streams and stuff. And so I'm practically my least anxious out of the entire day when I'm doing stuff like this. And so, because of that, I wanted to jump right into grade -2. I didn't want a break. This is what I find fun. To me, taking a day or two off feels like a break. And so, there could be a break because you never know what'll happen in life. And I have parts of my body that are still a bit messed up. I could need shoulder surgery at some point in the future. My shoulders have issues with them. I'll discuss that at some point in the future. Not in the near future. I can walk good is the important thing. My leg surgeries work good, so I am good to go for the foreseeable future. But there could be a time in the future where I need some surgery or something because I've been through a lot, or something could come up with my family or whatever, and then I will choose that time to vanish for a couple weeks instead of that vanishing having to occur in between seasons. Nothing terribly dramatic was happening in my life a few weeks ago, and I felt I enjoyed making these, so I was like, let's go right into grade -2 right now. We'll save our break for later. So, in any case, that's a reminder to people who are like, why do you make so much content between the two channels? And it's because I'm a bit neurotic about spending a lot of my day writing down stuff or creating other forms of art. And this has become the form of art that I've made in my life or form of teaching, the form of either of those that has by far the most people know about it or interested in it or whatever. So this is something that taps in great to my natural neurotic desire to spend a lot of time working on some sort of art or another. I call it art. A lot of people just see this as teaching, but I like to do different things with this channel. It's been really math heavy recently, but I try and make the math have some art to it as well. So someone says, let's do base 7 next, and I'm sure next week we'll have some degree of that. I don't know how dedicated we'll do mod 7 in next week, because we've already done some other things like mod 5 will have a lot of similarities. However, 2 reasons we'll do it. One is that I've been going up the mods, and this was mod 6, so next Monday, why not talk about mod 7? And the second reason is that weekdays go in 7-day cycles, so just like mod 12 gives us analogies for these type of clocks, or mod 24 or 60, mod 7 gives us analogies for weeks. For example, I'll tell it next week. I was going to say a mod 7 thing, but okay, it's for next week. Somebody said, what's my goals? What do I want this channel to grow into? The sky's the limit. We can, I believe my ideas will, over time, continue to go further because I have a lot of things I want to bring to the world, and we're just getting started. So, really, I don't have an end goal. But as for my next goal, I would like the main combo class channel to catch up to this one a bit more. I also want this one to keep up its momentum. I want to get on more of those type of lists that somebody put me on last time where they're like talking about online math communicators and I'm next to Numberphile and stuff. I want to get a better team assembled to help me with tech stuff and with editing. I want to be working with more editors and other types of things. So it's not just me and my main camera guy, and then me going home to edit, and then me figuring out how to tag it and post it, and then all the other stuff. So I want to have a better team assembled so I can focus more purely on brainstorming episodes, delivering the episodes, and helping with the directing of what I want the visual look of the episodes to be and the visual look of the set to be. So I still want to, have my role as the host and the director and such, but I wouldn't mind working with more editors or other people who want to figure out other ways of doing parts of the process so I can focus on the parts that I'm good at and that I want to continue building skills at. So I'm getting ads again on here. I think that it must be something from the stream glitching. I don't think there would be that many ads YouTube puts when I didn't click the mid-roll button. I think whenever it glitches, they're showing a whole one, which is annoying. But thank you, folks, for letting me know that that's what it is like. I should have clicked that button. I would have made like at least $1 on all these ads they've been forcing on you guys. But no, I don't care about milking every dollar out of you guys. Don't worry. So, yep, lots of places this could grow, and other places. Another thing I want to do is to work with people to help me record music of songs I've written. That there is a lot of music I've spent a lot of my life working on, and the current era of music I make almost nobody knows about. I mean, you folks don't know about any of the eras, but most of you. But I have a lot of music I want to record and release, which will occasionally be coming out on this channel. It's not going to be like the main focus. I know some people do not want to see that much change in like, it's mostly going to be educational stuff here and scientific and philosophical experiments. But there will occasionally be like a music video and then like an announcement that I have an album on Spotify or something like that, because I have a lot of music ready to record, and I also want to finish more of my books, and those will all be to a degree in conjunction with Combo Class, because if you like Combo Class, you will probably be much more likely to like those things as well. Some of them directly correlated, like one of the books I'm working on is about Threevens and Throds, so that'll be pretty directly correlated. And someone's asking songs or pieces of music. I'm not really sure the difference of those, of what you mean. If you mean piece as in a written piece, like as in sheet music or something, then I mean, I have instrumental songs that I want to rap and sing over, that I have the lyrics written for and the instrumental songs, and that I haven't recorded them yet because I don't like figuring out new technology. And I used to be really good at recording vocals and stuff, and I kind of forget some of the ways of making that maximized and idealized. A lot of it will come back in my head once I sit down and fiddle around with it again. But I need to just go down that whole rabbit hole again of thinking about engineering my voice and stuff. And these ones will have words, and a lot of them are even involving some of what you could call pieces of music I made, which are the soundtracks of the Combo Class episodes, are beats I made, and some of those beats are parts of the songs. So some of them are currently at the piece of music stage, but will someday also be at a song stage. So now, let's see. I think I'm going to wrap up our stream now. I have some stuff to work on, but make sure you've all checked out the new episode on the main Combo Class channel, that prime factorization one, and be tuned for a lot more cool stuff as usual coming this week. Not sure when or what bonus content will be coming, but you know I like to stay busy, and I do know there will be, regardless, some short that I've already filmed coming out at some point this week on this channel, and another main episode coming out in a week or a week from yesterday on the main Combo Class channel, and lots of other fun stuff like that. You can also catch me at the cool links in the description. We got our Discord, our Patreon, and our subreddit. And if you got any clocks, you can catch me at that mailbox. So, love you all. Thank you so much for watching. As usual, fun teaching some random stuff, and hopefully people got something or another from this casual-ish stream. Let's see, does this illuminate the whiteboard at all? Not much, but it gets a cool reflection. So when we see if it illuminates the whiteboard, it doesn't illuminate it, but it reflects itself in a way. I don't know if you can see that. This is at a bad angle to see it. We'll get more cool footage of this later. Actually, I have cool footage of me with this, just didn't fit in the episode yet. But catch you all another time. Thank you for watching, and